Here I'm going to be continuing to look at calculus, this time looking at differentiation by rule. In a previous video I've looked at differentiation by first principles, but here I'm just going to show you a rule that is used to derive most polynomial functions, which are functions like x cubed plus x squared plus something x, etc., etc. What you should notice is that this will make it a lot easier to derive functions from the original functions rather than going through the first principles method. So if we just look at here, if you have a function which is y is equal to x to the power of n, then the rule for deriving that function is simply to take the power that you have and bring that power to the front. Okay, so that n has gone to the front and you're going to multiply that by the x term. What you also need to do is make sure that you take the old power of n down by 1, so it becomes n minus 1. Okay, and I'm just going to go through a couple of them now just so you can get used to it. So let's say we have our function y is equal to x cubed plus 2x squared plus 4x plus 3. From the previous function video we know that this is a cubic equation because the highest power of x is 3. So if we were to derive that, then the derivative would be dy dx, which is the change in y with respect to the change in x. And I'm not going to go through the first principles method. All I'm going to do is follow the rule for deriving a function. So that is, take the power of each term and bring the power to the front. With this, that 3 just moves to the front and the 3 goes down by 1. So this becomes 3x and the 3 goes down by 1, so it's 3x squared. I move along to my next term and I've got 2x squared. I do the same thing. I take the 2, I bring it to the front and multiply it by whatever is in front of the x. So it's going to be 2 times 2, which is 4. And I take the old power and I drop it down by 1. So that's x to the power of 2 minus 1, so it's x to the power of 1. And I'll tidy this up afterwards. I come along to my next term and I see that it's 4x, which is to the power of 1. Okay, we just don't normally write the 1 there, but what I do is I take that 1, I bring it to the front and drop the 1 down by 1. So that's going to be plus 4x to the power of 1 minus 1, which is 4x to the power of 0. Now we know that for anything to the power of 0 is just the number 1, so that is actually just the constant 4. But I'm just going to write it all out here and then I'm going to rewrite it in a second. What happens to 3? Well, the constant 3 is just 3x to the power of 0. That's just another way of writing that. So what I could do is I could take that 0, if I'm deriving it, bring it to the front. Okay, what's going to happen there is you're going to have 0 times 3, which is 0. And 0 times anything is 0. So whenever you have a constant on its own, initially, when you're deriving that function, that will just become 0. So let's just tidy up what we have there. So that's just 3x squared plus 4x plus 4. X to the power of 1 is just 1. So 3x squared plus 4x plus 4 is the derivative of that function. From a previous video, we looked at what that derivative allows us to do. Well, if I plug in any value of x, I get the slope at that particular point in the function. So for example, if I plugged in x equals to 1, then 3 times 1 squared plus 4 times 1 plus 4, which is equal to 3 plus 4 plus 4, which is 11. 11 is the slope of the tangent to the curve at the point where x is 1. Okay, I say tangent because a tangent is a straight line that touches the point on the curve only once. Okay, so the slope when x is 1 of the curve x cubed plus 2x squared plus 4x plus 3 is 11, where x is 1. And I could substitute in any other value of x and that will give me the slope at that point. And it just tells me what's happening to the curve as I'm moving along the x-axis. So we could practice another one of those. Let's say, for example, we have f of x being equal to 3x squared plus 6x plus 2. If I was to derive that function, well, in a previous video I called the derivative, if I've written it as f of x, the function, then the derivative is f prime x. And using the rule here, well, that's going to be 3 times 2, which is 6x, because that 2 goes down by 1, so it's 6x to the power of 1, which is just 6x, plus 6. Because that x to the power of 1 now becomes x to the power of 0, which is just the number 1, so it's going to be 1 times 6 times x to the power of 0. So it's 1 times 6 times 1, which is just 6. And as I said previously, all constants become 0 when you find the derivative. Again, if I wanted to, I could find the slope at any point on this quadratic curve by just plugging in a value of x. More importantly, it allows us to find things like turning points on curves, which I'm going to detail in another video. So the best thing you could do now, after looking at that first part of the video, I would say just practice a few more derivatives